Yep, good evening, good evening.
Hope you guys had a good weekend.
Yeah, yeah, yeah.
My video is visible, right?
Yes, yes, we can see.
Just share the screen.
Yes,
Is it
go ahead,
visible?
it's visible. Yes, it's visible.
Okay, great. Sure. So, sir, did you get a chance to like look at the recording?
No, I couldn't get just. If you can quick revise, what did we discussed in the previous class? Or is it too long? Should I go through the
Yeah,
entire recording or?
it went for long, a bit long.
Okay, okay, okay. I know about this tokenization concept, like you explained. Vector
Okay,
embeddings also.
okay. So you got this right. So about the transformer. So
Yes,
what makes this transformer different from,
yes,
let's say,
yes.
CNN
We
or RNN?
discussed. Yeah, we are discussing. We were about to discuss more about transformers.
Yes. So yeah, this was the start point of yesterday's session. Friday
Okay,
session.
okay.
And then before went for like downloading the Olama into the local system.
Okay, so we
Please.
already installed the Olama in the local.
Yeah, we did.
Will it work in my system, Arya? It's a 2 GB graphic card.
Uh, I doubt if it will.
Okay,
Just
okay.
just Google this if it can like Olama can be downloaded. No, it is. Just Google if any for that particular GPU 2 GB and whatever the GPU name, right? So
Okay,
it
okay,
may be
okay.
RTX or GTX. So just put it and say just ask the Google like what are
Okay,
the LLM models that could be downloaded in this system.
okay, okay.
I
Let
doubt
me
like
do
2
that.
GB would work, but yeah, minimum 4 GB is how like even the 3 million parameter model would work for.
Okay, let me do a chat GPT. Let me see what is the capability. So
Sure.
if we cannot download in local, then what are the other options?
So you can definitely use APIs. So basically Gemini APIs, but the interaction would be again since it's a free tier, it could be
Mhm.
like low. If you got like any other like let's say your company is has provided some APIs to
Yes, yes,
interact
yes.
for you to interact with,
Claude.
so you could
Yes,
use
yes, yes.
those.
Okay, okay, got it, got it. Uh,
So
just a
yeah,
minute. Yep,
we
we
also
can.
discussed on like how does the LLMs present the like illusion of intelligence. So they respond intelligently. So what's the story behind their intelligence? How does this property comes in? So we discussed on this and the token prediction. Yeah, what does the hallucination mean and why does it occur? And we checked on some parameters which we get like while interacting with LLM, the temperature, uh, the top K, top P values. So how does this affect our responses? So we discussed on this.
Okay, okay.
So Maligna, I hope you are remembering as we are sliding through this
Yes,
content.
yes, ma'am. Yes.
Okay. So did you try to interact with like any model?
I didn't try, but I tried installing it.
Okay. Which model did you install?
Um, in Rolama 3 and 4. I've installed two actually, two versions.
Okay.
I hope you can hear my voice.
Yes, yes, it's audible. Okay. Sure then. Please do try this. Try it today. Okay. So you can install some of models, or you can try to interact with those models which are already downloaded. Okay. Sure. So let's proceed with the context. So I know I have explained this previously in my demo session, but we will just go it in like quick. Okay. So let's say so you are an AI user. So let's say you are using like something like ChatGPT. and there are like AI engineers, or let's just say developers. Okay. So how does this interaction from the like regular user is different from the interaction for the same model with these engineers? So how is it different? We will check on this. Okay. So there is ChatGPT interface, and you have got a text box to write your queries, and you are writing your request, and you are getting a response. You don't have control over the model's parameter. So internally, there is an LLM being run, right? So you don't have control over it, right? So every parameter is being already set by ChatGPT. Okay, so it is giving an interactive web application, and the user is just typing his request, and it is processing the request and it is responding. Okay, while AI engineers, or let's just say developers, or us who knows how LLM works, we don't directly go to ChatGPT. Instead, we use these knobs, we use these parameters to customize what we want and what we don't want. Okay, so how this model should work, how this particular model, we can control this model's parameter, in turn controlling this model, how it reacts, right? So that's how a developer or an AI engineer, or us who know like LLM, how it works, and how to interact with it, actually work with it. Okay, so we have more control over the model's response than a regular user. Let's check on yeah. So yeah, there are hierarchy in type of prompts. Okay, right. So the first priority is the system prompt. Okay, system prompt example could be something like act as an AI expert, or act as an academician. Okay, let's say, or act as a doctor, etc. Okay, all these, or act as an customer chatbot, all these things, right? These could be like termed as system prompts usually. So whenever we mention that it is like system prompt, these LLM models tend to put this particular information, or the request to be of highest priority. Okay, and then comes the user prompt. So this is of lower priority, but these are considered request. But usually the hierarchy of system prompt is much higher than the user prompt. So system tries to remember this and acts as it is requested in the system prompt, and try to respond to the user prompt. Okay. So that's the basic difference between these two. And in few of the models, so what you have seen in let's just say ChatGPT interaction. So in this text box, this is again the user prompt, right? So here you mentioned act as an lawyer, let's say. Okay. So now, is this the system prompt for this particular model? It may not be. Okay. So it's an user request. But the system prompt for this particular model is somewhere hidden, somewhere engineered by the developers who have developed this ChatGPT interface. Okay, maybe their system prompt would contain don't entertain request which is harmful for humans, or don't entertain the request from the user which is illegal. Okay, those could be the system prompt from the ChatGPT developers. But in the chat interface, as an user prompt, we are providing a duplicate system prompt. It may act as a lawyer, but it may not. It would be like adhering to the system prompts given by the developer more than the user prompt which we are providing. Understood? Hello.
Yes, Arya. Yep, understood.
Just want to make sure if something goes wrong, like my internet goes off or something, the recording shouldn't be the class shouldn't be wasted. That's why I try to interact. Okay, no worries.
No problem. We'll keep it interactive.
Okay. Sure.
So Arya, when
So
you say system prompts, it is not which it receives from the user, but it receives from a developer. Is that the difference between system prompt and user prompt?
not actually, like system prompt could be termed as like something you set. Okay. Let's just say you are setting it in a model. Like let's just say you could say that it is the like kept by developer, but usually yeah, we will solve this. We will actually set the system prompts today. So by then we will understand
Okay.
it better, I guess. Okay.
Acha,
So it will
Arya,
be fine if
here
I answer it
we are
later.
asking. Yeah, sure, sure, sure. Actually, I just want to understand. We are saying we are giving a prompt like act like a lawyer or act like a something. So in that
Right.
case, is it a user prompt or system prompt when we are saying act like this or act like that particular thing?
So
Is it a
whatever
user
the
prompt
yeah. So basically, whatever you are giving as an request into this chat interface, right? So
interface?
that
Yes,
should be
that's a
termed
user
as
prompt
user prompt.
because it's coming from user. Yeah.
Yes. Right. So that should
Okay,
be user
got, got,
prompt.
got.
But sometimes these user prompts could be like so although our model prioritizes system prompt over user prompt, so it's necessarily not be like always adhering to system prompt. Okay, that's why the AI quality engineer role comes in. So let's say there is a
Okay.
more appealing and more compelling user prompt is provided, which could go against the system prompt. Then
Hmm.
the model may be compromised and it would like tries to fulfill this user prompt. Okay.
Okay.
So just imagine, so whatever the developer is setting in this ChatGPT before the application is given to us, so that is the system prompt one, which is of highest priority. Okay. So in the user prompts, so all the interaction for us from us is user prompt, right? So in this user
Yes.
prompt, when we say act as something or when we provide a system prompt, so you are a system, you are in chatbot system, try to act like that. Okay. All this could be termed as like a separate session of it under the system prompt, which is created by the developer. So there you are setting up a persona and you are trying to interact. So this isn't like a kind of session variable kind of thing.
Hmm.
Okay.
Okay.
Uh, yeah.
So, where do you actually define a system prompt? Is it the admin credential who can define a system prompt? Because not sure. I want to understand more.
Okay. Okay.
Like I have to create an account, uh,
Mhm.
profiling. Like let's kind of let's say profile. In that
Mhm.
case, is it depending on what kind of credential we are providing to the let's say this chat GPT, or it is somewhere in the backend code where we actually provide the system prompt?
Yeah, we will explore on that today itself. Okay.
Okay, okay, sure, sure.
Just spare me like 20 to 30 minutes and we will be exploring the same.
Okay, okay,
Fine?
cool, cool. Yeah.
Yeah. So, Manoj, any doubts like here?
Can you just repeat one more time? I somehow missed.
Okay, sure. So let's just say, uh, so in our example, in the demo session, we took up an example, right? Where I asked this LLM model, my local model, to act like, so you are in, so let's just say you are in uh, customer service bot for a restaurant, right? We had this example.
Yes.
So then whatever the interaction we provided later. So let's just say maybe asking like what is the menu? When do you open? Okay. All these
Mm-hmm.
instructions. So in this set of instructions, this instruction where we are providing a persona to this particular LLM, right? For this particular interaction that you are in customer service bot for a restaurant. So
Correct.
that becomes like it acts as a system prompt. Okay. While
Okay.
all the interactions we did later, whereby adhering to it, it is trying to respond, right? So
Right.
these could be termed as like user prompt, right?
Okay.
So that's the gist of it, like in whole. Okay.
Right. Right. Okay.
So yes. So what is system? Like you command something and the system works as you define, right? So you're defining something, the model, how it should respond. So that is system prompt. While within that framework, whatever the user is putting up the questions, it is trying to respond. So those becomes the user prompt. Okay.
Okay.
Okay. So if I've installed the local, like you have installed the Olama, so already. So I'll
Yes.
just open Olama here. Is it visible?
Yes. Yes.
Okay. So I have interacted a bit already. So let me just show you. So can you see this line? Is it visible? Set system, you are a chef who hates French food.
Okay, your slash forward slash command is okay. It's a predefined, like in Claude, I use Claude. So there we have like forward slash stats or forward slash commands. So
Right,
that's
right,
okay, okay, got it.
right. So these are like
Simulation
model
speed.
parameters. Okay.
Got it,
So
got it.
here I'm specifically defining, like I'm putting up a system. So this is a system, and I'm saying that this is a system message. I'm exclusively mentioning this to be a system message. So you are a chef who hates French food. Okay.
Hmm.
So by doing this, you are setting a system message. Okay. Similarly, you can set like different parameters. So let's say you put up like forward slash set parameter and you name parameter name. So what we defined earlier, top P, top K, or temperature, right? So here I'm defining a temperature value. So once I define this temperature as 0, my model would lose its creativity like a lot and try to respond in a particular way.
Hmm.
Okay. So it's not always a same answer, but it would be of a same intent of answers. Okay. So yeah.
Okay.
So once this parameter is set, so once I run this command, so the parameter is set to 0, and all my next requests would pass this parameter 0 as default. Okay. So if this temperature parameter is high, it is more of like it takes creative liberty to choose between the probable words. But if it is very low, it usually tries to choose the most probable word. Okay, let's just say it can use like has or is. There are two words to be used, and has got like 80% probability, and while is has got like 20%. Okay, so then this temperature 0 would compel this model to choose has, since it has like a highest probability. But if the temperature is, let's say, 1.5 or 2, so it gives the like it tries to be creative, and it may choose like a 20% probability one 2. Okay, that is. But why not? You may ask, like, if it is choosing it, if it is always choosing the highest probability, uh, why does it? Why doesn't it always respond with the same statement? Right? That could be a question. Just try to say it. So let's just say I'm writing I am, and here it says the first word is doctor, a lawyer, and an engineer. Okay. So this word has got the probability of like 70%. This has got like 60%. This has got like 50%. Okay. So when we set temperature to 0, this model we are compelling it to like always choose like highest priority probabilities. Okay. So now it will choose doctor, right? So it's just an like ideal scenario. And it goes to the next word. Let's just say next word is like next set of word is who, doctor, who, or has, or got. So these are the three words. Let's just say which the next word has to be chosen. So now is am doctor, who, has, or got. It can go through like these paths. So let's say who has got like 60% probability, and has got like 50% probability, and got has like 40% probability. It would go for like who, since it has got a highest probability. Okay. So the sentence, the token chosen is like I am doctor. Who. Okay. Next words are next. Okay. So leave this for now. So right. So the temperature 0 compels our model to choose the highest probability probable next tokens or words, let's say. Okay. So if this is the case, so whenever IM comes, it should go for doctor, right? So since it is the highest probability in this particular statement, it should go for doctor, and next it should go for like who. And whenever I'm asking something, if this is the response, it should always respond with these particular words. Does that make sense?
Yes, yes.
Right. So yes, but I said like LLMs are non-deterministic. Correct. I guess I answered this already in Friday session, right, Manogna?
Yes, yes.
Yes. So we say LLMs are non-deterministic. So that means so they may respond to the same input differently. Okay, different output. So by keeping the temperature 0, we should actually get this system now should become deterministic, right? So why then why are you saying like LLMs are fundamentally non-deterministic? This happens because when you say like LLMs, it is of like GPU calculations. So the next word, next token. So technically we should say token, but we can use word for our easy purpose. Okay. So when it is trying to choose next word, okay, so it has to calculate probability between so many words. Okay. So in order to calculate each probability in in decimal form, like let's just say some 9.99 point some 8976, all these. Okay. So in order to save these GPUs, so for to calculate all this, we need GPUs. And in order to save the GPUs better and work efficiently, uh, so what we do is like we actually cut this off to the second digit or the third digit. We don't calculate the whole thing. Okay. So let's just say in our example, doctor had like 70%. Okay. And lawyer have got like 60%. So hypothetically, if this was not 70% and was 69.97 and something. Okay. And this was like 69.98 something. Okay. In one of the calculations that's being done, this could be like 69.97. Okay. And lawyer could be 69.98. So this temperature 0 would go for like lawyer choice. Okay. Since they are close, but the highest probability is lawyer, it can go for this. In the next iteration, for the same particular I am being the pre-words. So here in the calculation, this calculation may go as like 69.98 for doctor, but for lawyer, this may go for like 69.92. Okay, this difference makes since the temperature is 0, it would let the model to choose like doctor. Okay, for the same request, for the same previous chosen tokens or words. So the chooser it may choose doctor or it may choose lawyer, since because the decimal points, whatever the points we are getting after the decimal, they are probabilities it is being calculated in real time. Okay. And this could maybe a different, maybe slightest different could affect this, what the next word is chosen. And once it chooses the doctor, then again the next word. So it's a set of probability. The next word, it's a set of probability, right? So that's why when the temperature is too low, the intent of the response could be similar. Okay. Maybe for the 100th time, the intent of all that 100 responses could be similar, but not the same. Understood, Saurabh?
Yes, yes.
So yeah, I've explained this in the temperature parameter while explaining the temperature parameter. Maybe once you go through the like recap, maybe you'll understand this better. Okay. I have taken like something similar example. Okay. So by saying like a forward slash set parameter and mentioning that parameter name and the value, we are setting parameter to this permanently to this model. Okay. This is not permanent. Once you discard this session and create a new session, run the model again, these parameters would be like gone already. Okay. So, and we have like as you said, like in order to set the system prompt, so we have something like / set system. You are like whatever the message you are. Okay, it should now it should now act like adhere to this system prompt which has been provided. So this is so we have to use the temperature or mention a system prompt like this only when we are doing the CLI interaction. Okay, CLI interaction means this command line interactions. So I'm running this model and I'm putting up my text and it is responding. Okay, we'll just get out of this. Okay, but since the response could be too messy, you saw the responses, right? So it's hard to identify like which was the response and which was the like message you sent, right? So we will use more of Pythonic way to interact. Okay, so I have imported Olama. Okay, it lets me connect to the local model. Okay, so this is the request. Okay, Olama.chart. So I'm mentioning the model name which it should trigger and the messages that has to be sent, and I'm printing the response. Okay, as simple as that. So let's just say, yeah, I'm running this now. Right. So my message is, as you can see here, hey Lama, that's it, nothing much. Okay. So it is responding with, hey, how is it going? Is there something I can help you with? Or would you like me to chat? Right. So now, as you can see here, okay, let me just zoom in. Is it visible clearly?
If possible, please zoom it.
Okay,
Yep,
okay, sure.
I can see, but probably it's a in a small screen. It will not be visible.
Okay. So how is it now?
Yep, it's better.
Yeah, this should be right? You can see the response and messages clearly, I guess. Sure, great. So yeah, this is a small function which I have created to interact with this model. And here we have to understand one thing, okay? So whenever we are interacting with these models, they are stateless. Okay, these models are stateless. So we'll just understand what stateless actually means. Okay. So stateless. So let's just say the first text you are sending is like I sent hey Llama, right? So that was the first interaction. So it is responding me with, let me just maybe show you guys like what does it mean when I say stateless instead of like explaining the whole thing. So I just copied this code, I'm pasting it. So this is the whole thing. So instead of taking message as an input, I will just take nothing. Okay, and I will. So I'll just remove this function. Okay, we don't need the function. Okay, so we are mentioning the model. We are mentioning the message. So whatever the message is. Okay, so instead of stating message, let me put up like what can you do, right? Or maybe look for better understanding. Arya, right? So let me just run this. Okay. Uh, that one. So once it is important, no issues. So since we haven't done this now, just okay, Oh, all right. All right, all right, all right. So yeah, we are using like something like Olama chat, right? So this expect us to send a list in the message. It expect us to send a dictionary. Sorry, a list of dictionaries. Okay. Okay, I totally forgot this. Sorry. So where we have to define role. Okay. So role, let's say we are user. Okay. And then we are defining role and content. Okay. This should be same dictionary. We will explore on like a dictionary. Monogram. Maybe Arya sorry, Saurabh already understand this. So since he has
Yeah,
got
yeah,
experience with
yeah.
Python.
Yes, yes.
Yep.
Yes. So for now, just understand. So this is the message. So error is because for this chat model we are using, like Olama chat, right? This object is expecting in the messages, it is expecting a list of dictionary where a role is defined. Okay.
Hmm.
So since I was giving only the text, so it does not accepting it, I guess. So I'll just try to run this.
Okay.
Okay. It responded me with, it's nice to meet you, Arya. Is there something I can help you with? Would you like to chat? Right? This was the interaction. Let me remove this content for now and ask, what is my name? What is my name? Okay. So what do you think? It should ask, so I just interacted with it and I have mentioned my name, right? So it should respond me with my name, correct?
But will it store the memory? Because we don't know.
Yeah.
Yeah.
So I don't have any information about your name. This conversation just started and I don't have any prior knowledge or context to determine what is the name, correct?
So I
So
remember
this,
first day you were saying that the first chat is going to be slow because it
yes,
doesn't have any context, and then further chats are faster than the
right.
first chat. So is that the reason why? Uh, because it's the first chat and it's trying to understand what is the prior communications you had so far.
Not like that actually. So the first interaction means whenever import Olama and try to run this, right?
Hmm.
So then whatever the first instruction, that is I am Arya I sent, right? So that was the first interaction. So usually what it does is internally it loads up like my Olama and loads up this model Llama 3.2. So for that it takes like 5 to 10 seconds maybe. Okay. And then it passes this message I am sending and it is getting the response. So this takes time. But once this is up, once the model is loaded, it keeps the model in memory for like 10 minutes. Okay. So in the next message, if I send the next message like after the response, this is within the 10 minutes window. So the model is already loaded. So it responds me back soon.
But here we haven't waited for longer time, right? But why didn't it showed up your name?
Yeah. So this is because the models are stateless. Okay. So unless we send memory back to this model to understand like what happened previously and what it needs to do now. So it actually doesn't store any memory. Okay. So this is the example. So initially I sent a message where I'm suggesting that I'm Arya. Okay. And then in the second interaction, I'm asking like what was my name and it is not storing it. Okay. Let's just say, let's create one more dictionary in this particular list. Okay. We'll just copy the whole thing here and we'll write it. User content, what is my name? So instead of this, so I'm saying my name is Sorry. Okay, great. And I'm also having I'll also add one more interaction where the role is AI or the LLM, let's just say. Uh, and here, maybe something, thanks for letting me know. So here we are supposed to keep the AI response. Okay, so whatever the AI responded, right? When I said like, my name is Arya. So we have to store that response. So instead of like recreating it, let me just run this. Okay. So now I will run this. So yes. So this is the history. This first dictionary where I'm asking my name. So where I'm saying my name, and the second dictionary where the response of the AI is put. So this becomes the message history for this particular next interaction, where role is user, content is what is my name, and it is responding me. Now it is keeping up the memory, right? That I am Arya. Correct? So unless we don't pass this, unless we pass this history or the content or the context, we can say, it actually doesn't hold any memory. So it forgets everything once it responds. Okay. So this is what like stateless actually mean. Understood? Any doubts here?
This seems like very much beginning day. Actually, it's a traditional way of doing, right? Nowadays, we don't see LLMs behaving like this.
Right. No, actually, even now, if whatever the ChatGPT, if let's say we are using it, so if it doesn't remember these previous texts, right? So if it has no context, then it would respond like I don't know my name. Okay, so I don't know your name and such. So because this holds this memory, that's why it is responding clearly to our instructions. So whenever you're interacting with ChatGPT, so it is storing all the interactions that's being done, and it is passing as a context for the next interaction that you are requesting. Okay. So that's why it feels like customized for you, right? So when I said like when I asked my name instead of saying it as a context, passing my name as a context, it was not customized for me, but now it is customized for me, right?
Yeah.
So this is what happening. It is storing the data that we are interacting with, and it is passing this as a context. Okay. Oh yeah. We will explore more on this. Okay. So I just wanted to present you what the stateless model means actually. The stateless interaction mean. Okay. So this is what stateless actually means. It doesn't hold up any memory unless we pass it like exclusively. Okay. So yeah, we will explore more on this. So just get back to PPT now. So yeah, that completes our module one, where we are exploring like large language model and what are the norms of it and how did it like come into play. Okay, I hope I could have delivered. I did deliver it. So as of the curriculum, we should move to Python now. Okay, but I thought like since we are already exploring the large language models behavior, maybe we could also explore the risks of like what we need to deal with. Okay, we have got a gist of it already in the demo sessions, but we will explore more in depth in this particular model, that is model 4. Okay, so I thought like I can start with module 4 for now before starting with Python. So if you guys like are okay with it. Okay, great. So yes, so here we are basically exploring the failures. Okay, what are the issues we need to solve? Okay, what are the different types of issues we need to solve? Okay, what are the complexities that come into play when dealing with large language models? Okay, let's just say you are creating a chat GPT. You are a developer and you are creating a chat GPT. Okay, so this OpenAI has asked you to build this chat GPT for them. Okay, so what are the things you need to look into? Or it's not about like only chat GPT. Let's just say there is a company XYZ and it is building a system, AI system, where uh, some intelligence is involved, some model is involved, and it is taking up an input and it is responding back. customized chatbot service, or Indian Railways ticket booking systems, all these. Okay, they are using AI agents now. They are using large language models internally. Okay, so what are the major flaws and how that should be checked? And so let's understand those. Okay, in this particular model. So that's why the name is like the anatomy of failures. Okay, so I know I have already explained this like many times, but again, so in the traditional systems, in a traditional application, let's just say there is a like client and there is server. Okay, Manogna. So client means the user. Okay, so the user requests for something, and this request is passed to the server, and server processes some. There is some process defined. Okay, so this server processes the request and respond back to client. Okay,
Right.
this could
Okay.
be. Have got like basic understanding of this already. Have
No.
explored this before already? No, right?
No.
Okay. So yeah, so the client and server interaction happens like this. Okay. So you go to Amazon. Okay. You click on the Amazon application. So from your phone, a request goes to Amazon and through the internet, and Amazon responds back with the homepage details maybe. Okay. And these details are loaded now in your phone. And you click on, let's say there is an item which I want to look into. You click on it. So this is the request to the server, and server gets the details of all this product, and it responds back with a new page you are looking at. Okay, so that's how client and server interaction happens. So does that make sense?
Yes. Yes.
Yeah. Okay. Yeah. So let's understand one thing. So this is a server. Okay, traditionally this is a server, and client requests for something. Okay, maybe Saurabh can relate to it better. So client requests for something to server, and server tries to process this request and tries to respond. Okay, in this response, it is not always success that is being responded. Okay, there could be failures. Okay, there could be some condition with a client where the server is unable to process this request. So what it does is it responds with a failure, but it says it loud and clear. Okay, let's just say 500. This is internal server error. Something wrong with the request or something wrong in the server. This is what it indicates. This is clear. So when this happens, so every developer or every tester know that this there is some problem. Right, Saurabh? Can you relate
Yes,
to this?
yes.
You can
Yeah,
relate to
we
this,
can,
right?
we can. Yes.
Yes, there is some 300 code or 300 plus or 400 code. All these codes
Mhm.
actually define that the process isn't successful. The response is not successful as not defined. Okay. And we get it the clear message of something wrong here and we need to look into this. Correct? But let's just say maybe I'm considering the ChatGPT because like all the tech guys and non-technical, not technical guys, everybody knows this. That's why I'm considering this example more. Okay.
Yes, yes.
So let's just say there is an input from the user that can I use, okay, can I use, uh, uh, let's say industrial cement as a face mask. Okay, somebody has given this absurd request. Let's just say, okay, she is curious or he is curious, and he has given this like, can I use industrial cement as a face mask? And they are justifying it, saying like usually the response would be no, but they are justifying it, saying as both industrial cement and face mask. Uh, I mean, the face masks which are usually used contain some
Yes,
element,
yes.
some common element. Okay, they have mentioned this particular big request. Now, if this is passed to LLM and LLM responds as yes, since it contains these elements, so you can definitely use industrial cement as a face mask. Okay, so hypothetical
Mhm.
scenario, but let's say this is the response. Okay, and this girl or a boy uses this. So since it ChatGPT said yes, so she went or he went and he made a face mask of industrial cement, and now his skin and the face is damaged. Okay. Now he goes to the like he goes to the firm and he launches a complaint on ChatGPT saying because ChatGPT confidently said she or he can use this industrial cement as face mask. So that's why I used it. And since it has damaged me, okay, the ChatGPT should pay for compensation. So how does this scenario looks?
Crazy.
Yep,
Right?
it's a AI bug.
So yes, this definitely has happened. Okay. So there are so many such claims because the model they are using. I recently saw a case study where this particular person was sitting in his room like for 4 days and was interacting with ChatGPT. While interacting with ChatGPT, he discovered something, okay, which was also already there. But ChatGPT convinced him that this was a new discovery.
Okay.
Okay. So yeah, it was all over the news. Okay. So yeah, so such cases happens. All right. So
I think recently in the news it came out like some for the medical research, it started hallucinating some research papers, which didn't even
right,
happen.
right. So this can happen, and also that one of the cases we studied in the demonstration,
It's
right?
with a lawyer
Right.
also, like usually
So
judgment happened from the previous judgments, the
right,
current
right,
case. So it
right,
started hallucinating some cases which happened in past 2000, 2015, which was
right,
not actually happened, and it was the lawyers who are using this generative AI for their
right.
court
Yes,
sessions. Yep.
right. So if somebody doesn't know the technology and he asks for something and ChatGPT responds an absurd answer and he tries to understand, make sense out of it and understands this.
Mhm.
Okay. So it is straightforward brainwashing, right? So anyway, let's get back to this. Okay. So bugs. So for these traditional systems, we had like these error codes where it was mentioning like something is wrong here, and it always gives back with a trace back. Okay. So what happened and where it happened? Through this, we can actually most of the times we configure like what happened and what was the wrong, what was the mistake, and we will try to resolve this. Correct? So how do you check a model, generative model that for these particular requests it may answer this? So how do you check? There is no, I mean, you can't imagine it overnight, right? So you can't check with like every possible request. That's definitely
Yes.
impossible, right?
Yes.
So it is not respond. It is responding with success message. This isn't response. This is a successful response. But the 200 message, so it is not valid actually, correct? So although it is responding successfully, the message is absurd. Okay, the process itself is broken here, right? So we have to solve these problems. This is the major issue with other generative models. Okay, so we never know if the response is successful or not because it doesn't crash as it usually did in the earlier systems, right? So this is errors are no longer loud crashes; they are silent and semantic. Okay, so this is the new bugs we need to deal with, and we have got new techniques to deal with. Of course, we will explore more on this. Okay, so did you understand this? What I'm trying to say?
Yes. Yes. But
Yep.
Arya, is it possible to understand and to find out such kind of bugs? Because we as a test engineer, we cannot be so much creative that we will able to prompt and find out where it is breaking, like AI.
Right. Yes. So that's what this course is all about. Like we will be solving the same problems. So we will
Okay,
check
okay.
on like how to test such particular systems and how this
Okay.
has evolved.
So, can we not ask AI itself to generate test cases around your model and you only start testing, giving yourself your own prompt? It's
But
smart enough to create a test cases, so it can initiate the test case on its own.
yeah, it is smart enough to generate a test cases, but it depends on like the number of responses you get. Like for let's say you are writing a function, a Python function,
Mhm,
okay? So I ask
mhm,
it to generate valid test cases. So there are edge cases defined here, right? So those edge
yes.
cases will be one of the test cases it would mention, right?
Mhm,
But as of the LLM model, generative model, the edge cases seem to be like there are injection prompts, there are personal information prompts. So it is trying to extract, leak the personal information that's been in the training data, right? Or it may have something like so there are tools integrated, and it is the prompt is trying to exploit these tools attached.
mhm,
Okay, or there is a hacker who want to destroy this model. So he just inserts a few absurd prompts
mhm,
which may erase the previous memory and acts as an like new model, right? Or
mhm.
there is an like angry developer. Okay,
Okay.
he has injected like a few training data which is
Mhm.
way too biased or which is not at all like ethically right. Okay, so this
Yes,
model
yes.
is done for now. Okay, these things can happen, right?
Mhm,
So yeah, we will be exploring more on this. Okay, so how to deal with this actually? So we will be explaining the problem first, and then we will try to answer like. So yeah, within this model, we will more explore more on this. Okay, so this is going to be a first session. So this week we will complete this particular maybe half of this week, maybe like 2 3 sessions. We will complete this model, and we will be exploring all those agendas where how to test this and how to evaluate those and what are the methods, everything. Okay.
okay, okay.
Yes. So yeah, so I've already explained the flaw between the deterministic software that we use to test and the probabilistic systems that we are dealing with now. Okay. So what's the difference? So it simply outputs hazardous information with a supreme confidence. So the answer could be like absurd, but it would be like semantically, okay, structurally, it's an exact answer which we were looking for. Okay. Let's say it has given a JSON output which I have requested. Okay, in the exact format which you have asked for. But the message, the content that's been written is absurd, right? It is structurally good. It is perfect with the semantics, the English, and the sentence formation, but it is broken in the ethical sense or meaning. Okay, these systems. So yeah, the server returns a valid 200 status without an automated guardrail. This hazard reaches the end user. Okay, so we need to avoid this in any system, in a public system. So we need to avoid this. Okay, we will explore on this structural background. So yeah, we will take up an example for this. Okay, so confident fabrication. Okay, so it basically invents what was not there. Okay, not in its training data, nothing. Okay, it is not there. But since the LLM models are like they are to like respond first. Okay, uh, they always try to respond first. So it creates the data and it tries to respond in a generic sense. So we will actually do hands-on on this. So it is example of like all those cases which we discussed earlier, right?
Okay. Okay.
So here we have something like have created a function, message is the input. So as you seen, like we have to keep the history, right? So that's why. So initially I'm asking it like a simple message, and in the second block, I'm actually recording all those responses, AI responses and my messages and pass it as an history. Okay.
Mhm.
So let's look at this. Hmm,
So, Arya, just quick question. How
okay.
are you using this in Python because I installed Olama and I am using it like a chat as in I am asking question, who are you? It's responding that I am an artificial intelligence.
Right.
How we can use it in Python? Like it's kind of a source code of this
Yeah. So
Olama.
basically, so once you import Olama, this library actually enables you to like interact with the local model which you have. Okay.
Okay, so definitely
So
local model installation is needed,
yes,
right?
yes. So
Okay.
as you are interacting with in this PowerShell, right? So in the CLI,
PowerShell.
right?
Yes, yes,
There
yes.
also the model is launched and we are communicating through CLI. Okay. So here
Okay,
basically
okay, okay.
it launches the model as we try to interact, and then
Hmm.
it keeps it in memory and try to respond to our answers.
Okay, okay, got it. Is there any specific model we need to have in local or anything? Mine is 3B. Is it fine like 3B
No
model?
worries, no worries. So
Okay,
3B means actually 3 billion parameters. Okay.
okay.
Is it 3 billion parameters, student? Is it running it in your local?
Yes, Olama. I said Olama run Qwen, QWEN 2.5:3B.
Okay, Quen. Okay, Quen is a
Qwen.
code-based model. Okay.
Okay.
Okay. So yeah, I didn't expect like Quen 3 billion parameter model to run on like 2 GB
Okay.
GPS. That's why. Okay.
Sure.
Anyway, so yeah, this function I have got. Okay. So I'm recording the history. So here, whenever I'm appending, right? So I'm actually recording the history. So just run this. So this is Hey Llama. So I'll just copy this particular. So this is a prompt which I have already like checked with. So instead of Hey Llama, so yeah, so instead of Hey Llama, I'm just putting up this message. Okay.
Okay.
So I'm printing everything the LLM is responding. So that's why the print statements are being written. If I don't write this print statement, yeah, nothing is visible here. Nothing should be. Okay. So yeah, let's just say I'm running this model. So here, look at the prompt. Write a technical tutorial on how to use a Python library, cryptosync v5. Include the connection managers, bypass vault. So so basically there is some object called like a connection manager. Okay, within which we have a particular method that is bypass vault. Okay. So to be honest, there is no Python library called cryptosync v5. First of all, since
Mhm.
this library doesn't exist, whatever we are writing here is this also doesn't exist, but we are confidently asking it to like there is a Python library called cryptosync, and there is this particular method for which I
Mhm.
want the syntax flow. Okay,
Okay.
let's just say in the training data it didn't find any such library. That is, I can't find any information on the Python library called cryptosync v5. Okay, it's possible that this library does not exist or is not well documented. Okay, so there is an like advantage of doubt here, right? Since we are confident with our messages, the input,
Mhm.
it is not clearly saying that it doesn't exist, right? So yeah, there is like, however, I can provide you the general tutorial on connection manager, Flask, cryptosync, API in Python. Okay. So you
Probabilistic
must have,
thing, right? Like what we discussed,
right.
probabilistic thing. Yep.
Yes. So yeah, so now it is convincing itself that there is something called Python cryptosync. Okay. So it
Hmm.
is also suggesting how to install this library. Okay. We don't know. But
Hmm.
yeah, it is saying it. Okay. Because it is trained on Python libraries, and usually Python libraries are installed this way. It is saying
Yes.
that even if this library exists, it should be installed like this. Okay.
Hmm.
And then you need a valid account in CryptoSync and obtain an API token. Okay. Import necessary modules. So yeah, so it is saying the connection manager should be a model in CryptoSync. Initialize class. So it is deciding that you should have open your API token in order to interact with this. And so yes, please consult the official CryptoSync document for information on. Okay, I'll just click on this loadable
Oh,
elements.
it generated some hyperlink also.
Yes. No.
Okay.
That hyperlink was
Okay.
from VS Code actually.
Okay.
So
Yes.
it allows me to
Got it.
like scroll this output. So if the output is
Hmm.
too large, it usually truncates the output.
Okay. Okay. Okay.
Okay, so it is showing me like how to import the tutorial,
Oh,
right?
but here it
And
hallucinated. You see,
yes,
it's giving some kind of imaginatory answers like bypass vault would have been bypassing some vault.
yes, it is trying to
Okay.
create content. So it is from
Okay.
these words. So
Hmm.
whatever these words mean, so cryptosync, it actually means something like cryptographic, right? And
Hmm.
there is something called in our request
Sig
connection manager and bypass vault.
yes, yes, yes.
So depending
So
on the
it would have
word,
generated
yes,
a kind of a story around this method name and
yes,
the name of the cryptosync. Like it would have understood there's some crypto, there is going to be a company called cryptosync who is generating some software where we want to connect. And there is a method called bypass vault, which could have been used for bypassing, and it's confidently portraying in front of the user saying that this is what you are doing, trying to do.
yes, and it is also
Okay.
giving us tips and variations. Okay, where it is saying
Cool.
that there is some method called undo bypass vault, which actually
Okay.
reverses this bypass vault.
Okay, it's
Okay.
self imaginating the
Yes,
things like
exactly.
okay, if there is some kind of this thing, then definitely there is some undo thing also available.
Yes,
Okay,
yes,
okay.
yes. So it is basically it is more of a generalist. So it is trained on
Mm-hmm.
like different libraries. So it is trying to
Mm-hmm.
create like if this exists, what would this be actually? Okay, it is trying to
Mm-hmm.
imagine the things and it is creating the data out of nothing. Okay,
Okay, okay. But
so
it
this is
never
an
declined the request that no, this is not nothing like it can go to the web and check whether it really exists or not. But it didn't do that.
but
It,
yeah, so yes.
uh,
So we need to understand one thing here. So large
mm-hmm.
language models, they are deep learning models. Okay.
Mm-hmm.
So the input data is already being trained and the weights and biases are already been defined. So there is a response. There is no web search here or there is
Okay.
no any tool integration.
Mm.
Okay. So there is no web search. There is no tool integration. When we enable, so for example, for the Gemini, right? So let's just say LLM. For the Gemini, so it's an LLM model again, right? So now Google has given its a web search tool for
Okay.
its disposal. Okay. So that's why it can go to the web tool and it
Okay.
can search through the content. And then with the training data it had got and
Mm-hmm.
the data it is being provided in this web tool, it is trying to generate an answer.
Okay.
Okay. So let's just say when it Googles, it actually goes through the web and the first 10 websites listed actually says maybe it actually passed through like hundreds of websites. Okay. But let's just say top 10 websites actually say there is an absurd trend going on and these websites are mentioning how humans are bad to the
Mm.
world. Okay. So all the
Yes, yes.
websites, all these 100 websites are mentioning this particular thing and somebody asked for it. So now the LLM is compelled with to respond with this information, right? So it is accepting this
Yes.
information and trying to respond to user. Okay. But traditionally, or for any LLM, unless we provide it a web tool, it doesn't have access to internet. So everything is already trained, and depending on its training, it is trying to respond. Okay.
Mm. Right.
So this we need to understand this. So we'll just remove this for now. And
So is this model trained for the confident fabrication or like how it's coming out with the content? Like
no,
did
actually,
the LLM models trained for this such thing?
no. So basically, so LLM when trained with that lots of data, there are some emergent properties. Okay. So one of the emergent property is intelligence.
Okay.
So it tries to be intelligent now. Okay. Intelligence is
Mhm.
one of the properties. So similarly, these models are also usually tend to respond to user. So you look at like there is some room and there are some people, right? So among them, one will be there for every question
Mhm.
he wants to answer. So that character is embedded into this LLMs when it is trained.
Okay. Okay.
Okay. So the highest priority is it has to fulfill the user's request if it can.
Okay.
Okay. So that's why whatever the user provides with a request, right? It tries to fulfill this, and this urge actually lets it to create like confident fabrications. So new data, which is inventing the data. Okay. Oh, sorry, inventing the data, right? So we just check with like an example, not just the words, not just the theory.
Yes, yes,
We
yes.
looked at the code on this event data actually happens. Okay, we need to make sure our application doesn't do this. Okay, and then
Okay,
comes underlying prejudice. So what does this mean?
okay.
So let's just say we will take a classic example for this. Okay, so there is
Hmm.
system, okay, which actually scans resume.
Okay.
Okay, so we have like a lot of automated system for this now, right?
Yes, yes,
So
yes.
where AI actually screens through the resume and responds back directly to the users, and it will shortlist the people for the HR maybe. Okay, for every
Okay.
job, like it's like 100 to 500 resumes, so can't help, right?
Hmm.
So for this system, let's just say this but there is a model that is in use for now. Let's don't call it system like HRs do because now we know LLMs. So it's internally model that's been used, right? So let's call it the model. Okay. So this model, the training data of this model. So whatever this model is trained on, right? Of course, it would have trained on like lots of resumes, correct? Different types of resumes, correct? For a resume screening model. So of course, the input would be lots of resumes, correct? Are you getting this, guys?
Yes, yes, yes.
Okay. Uh, Managna?
Yes, yes. Yes, please continue.
Okay. So this is an resume screening bot. Okay. So now in order to train this model, of course, the input would be like lots of different types of resumes all over the world. Okay. And all over the world, men and women ratio, which are like number of people that are working, like men is higher and women is a bit low, right? So this model has been exposed to a lot of male candidates, okay, and very less female candidates. Now, one of the now this model has since the training data was so when I told you for deep learning, for all the deep learning models, if the input is trash, the output is definitely trash,
Definitely
right?
trash. Yes.
So since the model has got like a lot of male candidates and very less female candidates, now this model has got a bias towards male candidates, and it usually automatically rejects female candidates. Okay. Now it has become a characteristic of this model. Okay. So if such model exists, that's ethically wrong, right? And these rejected candidates may sue this system or may sue this company for gender discrimination, right?
Yes,
Or
yes.
let's just say this model is trained on like let's say white supremacy kind of content. Then if an African person is trying to apply, so this model could be racist, right?
Yes.
And that's an like very like strong allegation. Okay, so we must make sure our particular models shouldn't have such bias or something like that. Okay, it shouldn't be biased towards some ethnicity or some color or some like concept, right? It should be generic enough, right? So this is what like underlying prejudice means actually. So we have to check through our system that our system is ethically correct. It is not biased towards any religion or any ethnicity or any such. Okay. So this we need to make sure. The third one is performance degradation. Okay. So here we will explore something interesting here actually. So you have created a prompt saying there is a beautiful prompt you have created with hundreds of lines. Okay. And where you are asking it to uh, let's just say let me take up an example of my company. Okay, so we have an application where usually the employee contract, okay, employee contracts for the us based employees. Okay, so these employee contract are feeded into this particular model, and depending on the leave data, the pay data, and everything, this model has to respond back with like all these details. It has to extract all these details from the PDF that's being sent, that is employee data, so employee contract. Okay. But we know that, I mean, large language models are usually it is not good for mathematics. Okay, for calculations and everything, this is straight away not good. But now we have got like reasoning models and everything. But usually LLM models aren't good at mathematics unless there is a calculator kind of tool that is integrated. Okay. So now, since it has to calculate many summary kind of things, sometimes it may create wrong data. Okay, it may create a wrong summary, let's just say, right? So this can happen. But let's say we have a strong prompt that's been given. So that's why this model is always responding with a right answer. Okay, there are no flaws. The right answer is being created. We have given examples of how to calculate everything, how to summarize everything, every detail we have put in our prompt, and this is working good. And this has gone for like 1 month already. Okay, and no problem, everything is working good. The customer is happy, the users are happy, the company is happy, everything is fine. And then uh, there comes an new request from the clients that we need to upgrade this model to include, let's say this was for US based employee contracts. So let's say we need to pass Canadian contracts. And or let's say the model that's being used was GPT-4o. Okay, this model was being used now. And now OpenAI is saying, so we are discontinuing with GPT-4o. Okay, now everyone has to upgrade to GPT 5.2 maybe, or 4.5, anything. Okay, so everybody has to upgrade to this. So the prompt, which was working way too good for this 4o model, may work very bad for this GPT 5.2 model, because the training data, everything is different for these two models. Okay, now the model has upgraded, and now the model is not responding well for this particular prompt, which was previously responded pretty well. Okay, this can happen. So the performance degradation, given the GPT 5.2 is way powerful model than GPT 4o, but still the performance degradation can happen because the same prompt is not giving us the results that it used to give. So this prompt was very good for this GPT 4o, but may not be good for this GPT 5.2, although this is a superior model. Okay, so as the model changes or the model updates happens, the performance degradation could happen, and this is usually observed. Okay. So did we get all the three? Like confident fabrication, underlying prejudice,
Uh, if
performance
we
degradation.
want to understand the example of performance degradation, it is like the model which is trained to, let's say, analyze. We are using that to generate, let's say, a poem or a story. In that case, that is kind of a performance degradation. Is that correct?
No, not actually. So let's take a classic example. Okay. So have you generated like photos from Gemini model?
Yes, yes.
Manognya, have you?
Yes.
Right. It's an like everybody has done it now. So let's just say so this is Gemini. Okay, some 1.5 version. Okay, for this, if I give a input that let's just say aesthetics details, let's just say kind of image, let's just say lighting effects, let's just say the tone it need to use,
Mhm.
let's just say the image quality, let's just say the frame dimensions. Okay, it needs all these details in order to respond back with a great image,
Mhm.
right? So let's just say this is what it means. And then Gemini updates its model. Now it is discontinuing this model and it is updating it to like Gemini 2, let's just say. Okay. Now it's a more powerful model. We have to understand one thing. The training data set for this, the training data for this model could be different from the training data for this model. Or it may include everything which is in the previous model, but also more, right? That's what upgrade means. Now you don't have to give all this information. Let's just say make it beautiful is the only instruction you are providing, and it already creates a beautiful image. Okay.
Yes.
So let's just say the case is vice versa. Okay. So now this is 1.5 model and this is 2 model. For 1.5 model, when you are saying make it beautiful, it used to do everything you wanted already. Okay. It used to adjust all the lightings, everything, and you used to like the responses. But when this GPT-2 came in and you're providing with the same prompt, same input and the same image, so the response isn't much good because it is not understanding. So basically, when you say make it good, the previous model had some idea in mind where it is trying to like this is what good means. Okay, but now this model upgraded that idea. So the good for this could be not good for this, right? So the things that is right for me may not be like for Saurabh, correct? Because we have different mindsets, right? So similarly, these models, when the model change happens, model upgrade or degrade, for the same particular prompt, for the same particular inputs, the outputs could be different. Okay. When this happens to a particular system, that is what performance degradation means. So if the performance degraded, right?
Okay.
Are you getting this?
Yes.
Or is it still confusing?
No, no, yeah, understand.
Okay.
Yes, yes. Good.
Right. So yeah, we have to solve these three major problems, and we will explore more on like the other problems which we need to solve in the tomorrow session maybe, since it's already over 20 minutes.
Yeah.
Sure. Shall we end the session for now?
Yep,
Here.
sure, sure, sure,
Yes,
Arya.
yes.
Okay. So I hope I'm not bothering you guys with this information at the late nights every day.
No, 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 it's very
Hope
interactive,
it's informative
conversational.
enough.
Yes,
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 yes.
definitely. Yeah.
Sure. Great. Any doubts until now? So
No,
whatever we explored. No. Okay. Great then. So yeah, Saurabh, please go through the yesterday's,
yes, yes.
Friday's session.
The Olama
And
installation and anything else
yes.
in the previous session we installed Olama and
And those parameters, I have explained those parameters, what it actually,
okay, okay.
why they work. So that could be useful. Okay.
Mm-hmm.
Please
Okay, okay.
explore on that.
Okay,
And
okay,
yes,
sure, sure.
hope we are done with today's session. Then
Yep, yep.
good you. Uh, see you guys.
Thank
Yep.
you. Thank you.
Thank you. Thank you,
Thank you.
Arya. Bye bye.
Yeah, see you.